Okay, so this video explains how to do question 1.7 on the radiation sheet. So we've got the sun here, and the Earth is orbiting the sun at a given distance. The Earth's got an atmosphere around it, and on Earth we've got a roof, and we want to know how much solar energy is on the roof. So it actually asks for how much energy is incident on the roof per minute. So we're gonna go through the equation here. So the equation is Q equals sigma times area multiplied by T to the power of 4. So in this case, the area is the area of the sun and T is the temperature of the sun. So if you do this equation, you'll end up with a rate of like energy flow. So it's going to be Q dot. So that's like energy per second. So if you think about it, if you have a certain amount of energy leaving the sun and then it radiates out in a regular sort of fashion, so it's going to sound weird, but it radiates radially, so kind of like in a circle, if that makes sense. So everything a given distance away from it, no matter which direction it is, as long as it's the same distance away, should receive the same amount of radiation. So with that in mind, if you draw a circle around the sun, or if you make a sphere around the sun at the distance of the Earth's orbit, every inch of that sphere should receive the same amount of radiation. So if we've got an amount of radiation, which is Q dot, and we divide that by the area, we'll end up with an amount of radiation per unit meter. So what we're going to do is, hang on, I'll pause just. Yeah, so the first step is to get your Q by multiplying sigma by the area of the sun and the temperature of the sun. And then if you divide that Q by an area which is caused by the Earth's radius. So it's going to sound a bit strange, but imagine the surface of a sphere due to Earth's radius. That's the area you want to divide Q by, and you'll get the power incident per meter squared on Earth's surface. But this is ignoring the atmosphere. In the question, it tells us that the atmosphere is going to divide the energy by 2. So here's how you would divide it by 2. You literally do Q divided by 2 and then divide that by an area of a sphere caused by Earth's radius. So the previous equations gave you the energy per meter squared. So now we know that our roof has a given area, and we want to know how much energy we have on that roof. So if you multiply your current value, which would be an energy per unit area, by an area, you'll end up with a unit of energy. So the last thing we need to do is multiply this by 60, so we get the energy per minute. And that's basically how you do this question.